All right, guys, so here is your next project. It is about parabolas in the real world, okay? But first, I'm going to kind of guide you through things that you need to do. Again, this counts as a test grade. It will be 10 points off each day late, and I've written over here on the board, I'm not going to accept any projects after May 9th because I've got to get them graded and then the computer to figure out your exam exemptions as well, since the last day is coming up that following week on the 14th. So these are due Monday, May 5th. If you finish it early, you're more than welcome to turn it in at any time. So let's look at part A that is on here. So part A is you're going to practice converting your formulas and also finding key features. So you're given this equation. You want to find all of those key features that we did on your homework like we did Monday and Tuesday. Make sure that you show all your work. Then you're going to convert that equation to standard form for number 2, and then you're going to convert it into vertex form by completing the square. So you have to show it by completing the square in that step to get full credit for that problem. Okay, so kind of like a combination of what we've done this week with converting equations and finding key features. Now, in part B, I'm going to give you some points, and you're going to write the equation of the graph in vertex and standard form, making sure that you show all of your work. So I give you the vertex, and I give you just one additional point, kind of like the homework problems that we just went over. Then, once you have those equations, you're going to find all of these key things. Notice I put down here your answers should be exact points, no estimates or rounding. So like some of the answers that we had at the beginning of the week when we used quadratic formula to find your x-intercepts, sometimes they left a square root in them. So it would have to stay like that. All right, then part C is where you kind of break off on your own and you find a parabola in the real world. Now, if you look around this room, there are actually some parabolas in this room. Now, they may not look exactly symmetrical, or maybe they might be a little bit more pointy or things like that. But if you look closely, you can see some things that resemble some U shapes. So what you're going to do is you're going to find a parabola, and first you're going to take a selfie with it, okay? Then you're going to take another picture of the parabola that you're going to use in Desmos. So how many of you have used Desmos before? Okay, great. A lot of you have. If you have not, I can help you with Desmos as we go through. Then you are going to measure your parabola. So you can grab a ruler or tape measure or whatever, and you're going to measure the height and the width of it. Then you are going to take a picture of that, of you measuring the object, so that way I know the actual height and width. And then you are going to insert your picture into Desmos. You're going to move it around so that way the settings work out. And then you are going to find 2 points, at least 2, on your parabola. So if you're thinking about the problems that we did in homework, we needed the vertex and one other point, or you could have your 2 x-intercepts and one other point. So it's either 2 or 3 points that you need from that graph. You're going to take a screenshot of your parabola with your points clearly labeled, and then you are going to do what you did in the first parts A and B. You're going to convert your equations into standard vertex and factored form just like last night, and then you are going to find all the key features. Now, one thing about your points that you pick out of Desmos, like it says in number 5, your points must be integer values, no decimals. So like -2.3 or 1.5, but you can't pick 1.5 or 2.75. It's got to be an integer. So you may have to do some adjusting in Desmos to make that work out. Now, the last thing that you are going to do is you're going to put all your stuff together. Make sure it's organized and neat. All calculations are shown by hand on notebook paper. We're not typing them out or anything like that. And then you need to make sure that you either print off your, it could be 3 or 4 pictures, depending on what you have from those different steps. And then you put them on 1 to 2 sheets of paper. So you can either print the paper or you can share it with me in a Google Doc. But I don't want one picture per page because that's a lot to print off. So if you could make sure that your pictures fit on one sheet, or maybe two sheets where it's prints out as one sheet front and back, so that way I can look at it. And again, you can either share it with me or you can print it off yourself. Then you're going to put your work either on a poster board if you want, or you can just put it in a folder and give it to me. I don't want you to staple them because I need them separate to kind of go back and forth from the picture to the graph. So either get a folder or put it on that poster board. Again, projects are due May 5th, 10 points off each day late. No projects will be accepted after May 9th. Bonus, so if you want up to 10 points bonus, you make a poster displaying our 3 quadratic forms that we have, so standard vertex factored, with all of your information on it about how to find key features, converting equations, basically everything in this unit. Make a nice poster board of that, and that will give you up to 10 points. Creativity, accuracy of the information, that gets you the most points. All right, are there any questions about the project? Now, I have done a little bit of this before, so I kind of wanted to show it to you. So this is not actually my picture, but it's one that I stole off the internet. So I want to show you that real quick. Now, one thing that you can do is you can just go to Desmos and you can just type it in Google if you've never been there before, and it's just www.desmos.com, and you can click on the graphing calculator one that pops up, so it pops up like this. Then you can add your picture. If you hit the plus sign, you add your image that you took, and there's also a Desmos app on your phone, so I believe that you could kind of do it on your phone and take some screenshots as well. So mine was on the desktop, and there is my parabola. And no, I have not been here, and no, I did not take a selfie with it, but it's there. So let's say that this was a picture image, and let's say the image was a 4x6. So I want to take this image and move it. You have to move it by the center and make it kind of the same length as you had before. So if this was like a 6-inch length here, and maybe it was about 6.5 at the top. See how you could adjust the picture to make it fit? Make sure it's the same settings as the measurements. So when you measure your object, if it's 4 inches wide, make sure this part's 4 inches wide. Then you have to pick some exact values on here to kind of make it work out. And it depends on if you use the inside of your parabola or if you use the outside. A lot of people like to use the vertex, or maybe like to use x-intercepts. And x-intercepts work out well here too. But once you have your points, you can go over here and type them in, the ones that you want to use. So if I wanted to use my x-intercept, see how it puts a dot at 0, 0, and then maybe I want to use 6, 0 as my other one. And then I have to pick one more point. So if you use x-intercepts, use 3. If you use the vertex, then you only need 1 additional point. So let's follow this curve around. Is there an exact location or close to an exact location where this curve might hit? Maybe here, maybe at 1, 5. I know that goes on the outside a bit, but that's pretty close on that same curve, right? So make sure the 2 or 3 points that you pick have whole numbers. There's no decimals there. And you may have to adjust a little bit bigger or a little bit smaller to kind of go through and get that picture. But now that you have that, screenshot that, use those points, write your equations, then find your key features. Okay? The hardest part is finding the parabola. But if you look around, you can see things that are close. Facial features, heads could work as long as they make that parabola shape. You're going to use Mr. Lewis's head. You know, it works. I would say go with it. Are there any other questions about your project? Okay. Question? Yeah, as long as it makes that curve, and it can open up or open down. So when you go through and do your parabola, here, I'll just make a new, I don't think it's going to make a new picture, but it can be anything that has that kind of shape, like, oh, there it goes. Somebody used their Easter basket handle. Somebody used a Pringle chip because that opened up. Those are some examples that you could look at. If you have a picture of something at home, you could hold up the picture because you could also take a selfie with that too. Somebody used the smile on their teddy bear that they had because it made that parabola shape, so it could open up, it could open down, it could be real wide, it could be really skinny. If you look at your coffee cup handles, that's something that you could use as well. So there's a lot of different parabolas out there in the real world. You just have to find them. So any other questions about your project? Key thing is you got lots of instructions here. Follow these. But you could work on doing 1 and 2 at any time, but 3, just look around and try to find stuff. If you're going on the field trip tomorrow, you might see some parabolas somewhere else, but you're gonna have to take a little ruler with you and measure them real quickly. I'll bring some tape with us. We'll measure. Exactly. Yep. So when you're doing your project, if you go back up here to all the pictures that you need, take a selfie with it. That way I know you've seen it. Then you take a picture of it to use in Desmos. Then you take a picture of you measuring it, so that way I know the measurements were correct. And you can just estimate the measurements. They don't have to be perfect. So if it's like about 2 inches or about 4 feet or whatever, it's fine. Then you need to take a picture of once you insert it into Desmos with your points labeled. So that way I know that you have your points. So this would be your final picture. And you could just do a whole screenshot of this. So that way I see your points and I see your image. And then once you have all of those pictures done, that's steps 1 through 5. Then 6 and 7 are writing the equations, finding the key features. Any other questions? Those are good questions. All right, well, let's go on to today's lesson.